Hey guys, so in this video I'm going to do a kind of short example problem of curve sketching. So in this video I'm going to kind of talk about this simple cubic polynomial. We're going to kind of figure out how to sketch this using the tools we've been given so far in Calculus 1. Um, so my first move is going to be to take the first derivative. So I'll set f prime of x. It's going to be by the power rule 3x squared minus 1. Okay, cool. So the next thing I want to do is find my critical points. Remember that my critical points are the points where uh, f prime of x equals 0 or f prime of x does not exist. So let's take a look at this first case here. So if f prime of x equals 0, then we have that 3x squared minus 1 equals 0. So then I have, let's see, I'll have 3x squared equals 1. So x squared equals 1/3. And then x will equal plus or minus the square root of 1/3. Which, if you want to get nice here and simplify, it'll be plus or minus the square root of 3 over 3. Okay. So this is giving us our critical point here. So this is a critical point. So the other type of critical point is if f prime of x doesn't exist. Well, f prime of x exists everywhere because f prime is a polynomial. It's a quadratic. So we don't have any critical points of that type. So our next move is going to be to make a sign chart for the sign of f prime of x. So we're looking at the sign of f prime. And remember, our critical values are where f of x equals 0. So that's where, where f prime of x equals 0. That's where we have our kind of minimum and maximum, where our derivative is horizontal. So if f prime of x equals 0, we're looking at something like this or something like this, right? We have a local minimum or a local maximum, maybe a extrema there. So we want to test around these critical values for x. So I have my values here, minus root 3 over 3, and then I have positive root 3 over 3. Okay, so in this interval, I can pick 0 very comfortably as one of my test values. Let me put it in a different color here, that way we know it's a test value. Another one I can pick here is I will have, so root 3 is just less than 2. And I know that because I know that root 3 is less than root 4. And root 4 is 2. We're talking about the positive root here. So root 4 is equal to 2. So root 3 is less than 2. And I'm dividing root 3 by 3. So by positive 3. So root 3 over 3 is less than root 4 over 3, which is actually 2/3. So all of this tells us that root 3 over 3 is less than 1. So I can pick 1 here as my first test value over here. And similarly, I can pick -1 over here for my other test value. So let me move this over here. Okay, so we want to plug these values into our function that we got for f prime of x. Not f of x, but f prime of x, because we care about the sign of f prime of x. So I want to know what is the sign of the sign of f prime of -1. Well, if I plug in here, so I'll remind myself that f prime of x is equal to 3x squared minus 1. Okay. So if I plug in -1 here, this the square will make it positive. So I'll have 3 minus 1. 3 minus 1 is 2, so it'll be positive. So it'll be positive. So that means that this side here is positive. And then now I want to know what the sign of f prime of 0 is. So if I plug in 0 here, I get 3 times 0 is 0 minus 1. So I left with minus 1, which is a negative. So I have negative here. And then I want to know the sign of f prime of 1. So if I plug in 1 for this x here, I get 3 times 1, which is 3, minus 1, which is 2. 2 is positive, so it's going to be positive, so I have a positive here. So this tells me that my function increases here, decreases here, and increases here. Cool. Okay, so that's our first step there, is finding where our function is increasing and decreasing. Okay, so I just cleaned things up here. So the next thing I want to do is I want to find the points of inflection. I want to find when concavity changes. So in order to do that, we need to talk about our second derivative. So our second derivative, f double prime of x, is coming from here. It is going to be by the power rule, 6x, and then the minus 1 goes away, so I'm just left with 6x. So f double prime of x is 6x. So next I need to find the points of inflection. And remember my potential points of inflection, potential POI, are when f double prime of x equals 0 or f double prime of x does not exist. And whatever values make this true are in the original domain of the function. I'll put up a video of a problem that has an example where that is the case, where we have to worry about something like that. But in this, for this particular problem, we don't really have to worry about that because our f double prime of x is continuous over its entire domain, and its domain is all real numbers. So we want to find when f double prime of x is equal to 0. And that happens when 6x is equal to 0. Well, that only happens when x is equal to 0. So that tells me that x is a point of inflection. Or sorry, x equal to 0 is a point of inflection. So again, I'm going to make my sign chart here. Let me go a little bit lower here. And this time, I want to find what the sign of f double prime is, because we're talking about concavity now. So I need to know the sign of f double prime. So remember my potential point of inflection here is 0. So I want to find test values around 0. So I can pick pretty easy -1 and 1 here around 0. And remember, I need to plug these not into f prime or even f, but f double prime. This is what I care about. Remember that f double prime of x is 6x. So I want to know what the sign of f double prime of -1 is. Well, if I plug in -1 for this x here, I get -6, so I'm going to have a negative. Next, I want to know what the sign of f double prime of, +1 is. 1. So if I plug in 1 for this x here, I'm left with 6, and so it's going to be positive. So I have a negative over here and a positive over here. So this tells me that my function is concave down before 0 and concave up after 0. So if I was doing if I was doing this problem on a regular piece of paper instead of on my laptop, I would have drawn my sign charts on top of each other like this. That way it's maybe a little bit more clear to me what's going on here. So I just went ahead and reorganize things because this is irrelevant information that we need. Some other things that are going to help me sketch this curve is to figure out where my zeros of my function are. So remember that f of x is equal to x cubed minus 1. Sorry, x cubed minus x. Well, if I want to find some zeros, I need to find when f of x is equal to 0. And that happens when x cubed minus x is equal to 0. So I can factor here, and I get x times x squared minus 1, factor out an x. And now I can factor this x squared minus 1 as a difference of squares, so I actually have x times x plus 1 times x minus 1, and that equals 0. So this tells me that my zeros of f are when x equals 0, -1, and +1. Okay, cool. Now that helps me kind of sketch my curve. Now we can start. So let's get some things going on here. Draw a little graph. Okay. So I know that my zeros of my function are going to be at 0 here, at +1 here, and at -1 here. Now, in between those values, I have where my sign of f prime will change. So it's going to be here at √3/3 and here at -√3/3. Okay, so now let's think about what's going on here. So I'll draw my curve in yellow. So I'm increasing before -√3/3, and I hit 0 at -1, and I'm concave down. So I increasing here, concave down. So this must look like this. So notice that I'm coming up, I'm coming up, I'm coming up, but I'm concave down. I look like a frowny face. At √3/3, I start decreasing. Sorry, -√3/3, I start decreasing, but I'm still concave down here, right? I'm decreasing and I'm concave down. So I start going down like this here, and I hit 0 at 0 because that's one of my zeros of my function. Start going down, down, down. So now at 0, my concavity changes, and I start looking like a smiley face, right? So I start going up. But I'm still sorry, I don't start going up. I start curving up, but I'm still decreasing. So I keep going down, but I'm curving up. And then, so I'm going down, but I'm curving up like a smiley face. And then at √3/3, I start increasing, and I'm curving up like a smiley face. So I have this. So I start going up. Okay. And so I start going up. So this right here, I know it looks a little hairy, but this is what my curve looks like. So we've successfully graphed this curve. Now, suppose I wanted to know what these y values are here. What is the actual value of these points? Well, what I would do is I would find f of -√3/3, and I would find f of +√3/3. So we can do that real quick. This is going to be, let's see, -√3/3 cubed minus plus √3/3. And this is going to be +√3/3 cubed minus √3/3. So after doing some gross rational arithmetic, radical arithmetic, we get that our f of -√3/3 is 2√3/3. So that tells us that this point is -√3/3 and 2√3/3. And similarly, we get that this is +√3/3, and this is going to be -2√3/3. Okay, now here we go. This is our f of x equals x cubed minus x. Nice.